Hello. So far we have used activities in our programs. Activities require a UI and it is assumed that the user is looking at the screen. However, at times there are works which do not require a user to look at the screen. For such works we use what is called services. We have studied services earlier before, but today we will write a program that will use the services. We will continue with our photo gallery program, which is from Beginner Ranch Guide, and we will now use the services to enhance that program. So let's get started. So currently our photo gallery program is a very simple program. It connects with the Flickr and then it downloads some photos. So basically it is only downloading the recent photos. So that's how our Flickr fetcher program looks like. So it fetches these images from the Flickr and updates them on the UI. Now we would like to use services into it. So let's get started. So let's first create our first service. We will name this service as poll service. So poll service. Okay. As you can see here that I am using the files provided by the Beginner Ranch Guide. This is available on their website, so you can go and also download it. But let's develop the code here to have a better understanding. So our poll service extends intent service, which is one of the most common type of service that is used. Now, because we are extending intent service, it is asking us to implement the abstract methods. So let's do yes, and now we will go and we will say private static final string tag equal to poll service. Then we create a method new intent, which we will use to create the intent. Turn new intent context poll service dot class. Then we create poll service. So as you can see that this is a very basic code written to create a very basic service. Just like activities service also have a life cycle. So for example, when the service receives an intent, the method onHandleIntent is called. So now our first basic service is ready. It is a subclass of intent service. The service service is invoked by intent, and these intents are called commands because each of these command is an instruction to the service to do something. And depending on the kind of service, the commands could be serviced in a variety of ways. For intent service, for example, the commands are put into a queue and then intent service using a background thread takes out one command at a time and once all the commands are served, then the service is stopped and destroyed. So this is how the intent service works. Now let us first create an entry for the service in our manifest file. So we go, our activities are given here. We will now just create an entry for our service here. Service, Android name, poll service, because this is the only service where Android can make a guess. And now our service is added into the manifest file. Now let us add some code to start this service from our main class. So we go to our photo gallery fragment, and inside the on create of it, we create the intent new intent get activity, and then we start the service. Now let's run our program to see whether our service starts or not. Currently there is no indication except the log get message that will be printed. So let's watch our log get process, and application is running. So yeah, so you can see that we got a message saying received an intent. So this is the message that got printed from our poll service on handle intent method. So now we could see that our service has started, and in fact this is a good start, but this is not sufficient for us to just see a message in the logcat. So we will be doing some functionalities which are more suited for services than activities. So we will be doing some safe background networking using services, and services are usually used only for doing things in the background. So for example, our current application, it our current application makes a query to the Flickr. Now we are going to use a service to poll Flickr in the background. So we will have to add some additional code, which we will do right now. So let's start. So in the poll service, we start with adding some code to the on handle intent only. So let's start adding some code. So if network available and connected, then do nothing. So basically our service will check for the network availability, and if it is not, then it will do nothing. Now let's first implement this method that we plan to use. It should return a boolean and does not take any parameters, and checking for this is not very difficult in Android. So we start a connectivity manager, connectivity manager, and we get system service connectivity service. So connectivity service, and this service can answer us that if the network is available or not. So is network work available equal to cm dot get active network info, and if that info is not equal to null, then the network is available, otherwise it is not. Similarly, we can get is network connected equal to is network available, and cm dot get active network info dot is connected. Then we will do the return is network connected. So this is a very simple code which checks in the background whether the network is connected or not. So this is a good use of service, but we will not stop here. We will continue developing the program with services and will be doing more significant things using services. So just like you see, that is network available is a very small piece of code, but what it does is that it tries to get the connectivity manager, and if the connectivity manager returns a not null value, then it knows that the network is available, and then it checks whether it is connected or not. And if it is not connected, then it skips the rest of the part. So this is a very good practice because it allows us to optimize our application performance. That is, that when the network is not available, it does not try any networking operation. But now, in order to make this code work, we will have to add permission in Android Manifest. So let's go to Android Manifest. We already have a permission to ask for internet, but now we will have to add a permission to ask for the network state. So access network state, and that's it. So this is now a good complete code for checking for the network. Now our service will like to poll for new results. That is, if somebody else has uploaded photos on the Flickr, so we should make use of something what we call as shared preferences to store the last result fetched. So we have earlier studied shared preferences, but today we will see their use in a real program. So let's go to the query preferences class and put the ID of the last prefetched item in shared preferences, so that even if we start our application or restart our application, still we have the result. Last result ID. We will do two methods. One is a get method, another is a set method. So public static string get string get last result ID, context return preference manager. We have earlier seen that preference manager uses a key value stored to store limited amount of information. So get default shared preferences context dot get string preference last request ID null. So we get an error. Yeah. And now we do a setter, that is when we know the last ID, we should put it in the shared preferences. Void set last result ID context string last result ID preference manager dot get default shared preferences context dot edit dot put a string to preference last result ID and the last result ID dot apply. So now we are storing the last result ID, last ID of the image, and if we see, we will create a background service which will keep polling, so that whenever there are new photos on the Flickr, we can download them. So this is a very good use case for the service. Okay, so now what we have to do? We have to pull out the last result ID from shared preferences. We have to fetch the last result set with Flickr fetcher that we developed earlier, and if these results are same, then that is fine, but if it is not, then we know that user has updated the content. So that's very good. Let's start developing it. So let's go to our poll service. So let's first check why are we okay. So let's go to our poll service and start writing some code. So in our poll service, we are currently not doing much. So we can remove this log message and we can make a query. Query preferences dot get stored query. Pass the context string last result ID equal to query preferences dot get last result ID. Again we pass the context and then we get the list of item gallery items. If the query is equal to null, and items equal to new Flickr fetcher dot fetch recent photos, else items equal to new flickr fetcher dot search photos. So we will be developing some of these uh, methods as we need it, and the others may are already available to us. So if items dot size equal to 0, then do nothing. String result id equal to items dot get 0 get id result id dot equals last result id log dot I tag got an old result else log dot I tag got a new result. Now the last thing that we need to do is query preferences dot set last result id result id. So in this case we are making use of what we will call query preferences. In the query preferences we have a get stored query, set stored query. So in get stored query, and then we set the last result id. So we go to the poll service, and poll service is querying it and then setting the result id. So let's see how our app behaves. As we go down, the app fetches the new images. So this is fine. Now let us add some more functionalities. Now suppose we have a work which we want that for example we want something to happen after a given time. So let's say after 5 minutes something should happen. Now one way of implementing it is to use a handler, because the handler has methods such as send message delayed or post delayed, and this can solve the problem. However, the process will shut down if the user navigates away from all the activities. So instead of something like handler, we will use the alarm manager. So alarm manager is a system service that can send intents for you. So we will use the alarm manager to send us some intents, and using those intents will make sure that we do something after a given time interval. So now the question is that how do we tell the alarm manager that what intents it need to send, because we need to use a pending intent, and pending intent is something which we can uh, deliver, which we can get the system to deliver us after a certain time. So let's use the alarm manager with the pending intent. So we go to our poll service, and we do is to add a poll interval. So let me define the poll interval here. So private static final int, let's say poll interval, which is equal to 1000 into 60, so that is 60 seconds. So 1000 seconds is what I am giving, or sorry, I'm giving, so this is milliseconds, I'm giving 60 seconds, that is 1 minute interval. And then we define few new methods. So one of such method is public static void set service alarm. As the context takes another is a boolean, intent I equal to poll service 3, poll service dot new intent context create a pending intent pi equal to pending intent dot get service context dot 0 dot I dot 0. Then we create our alarm manager. I will be explaining the code very soon. Alarm manager equal to alarm manager context dot get system service context dot alarm service. And if the alarm is on, alarm manager dot set in exact repeating alarm manager dot elapsed real time and system clock dot elapsed real time for interval or pending intent. Otherwise, alarm manager dot cancel pending intent vi dot cancel. So now let us see what we have done in this method. So what we did in here. So first thing we did was to create a pending intent by using the pending intent.get service. It takes 4 parameters: context into which to send an intent, a request code to distinguish this pending intent from any other pending intent, the intent object to send, here we are sending a poll service, and this is a flag which may be used for advanced purposes, however it was not used here. Now the second thing that we did was to set the alarm manager, and we called the for setting the alarm manager we called the set inexact repeating. So this method also take four parameters. Number one, a constant to describe the time basis for the alarm, the time at which to start the alarm, the time interval at which to repeat the alarm, and finally the pending intent to fire when the alarm goes off. Now, in our case, we want the alarm to go off after each minute. That's why we are using this method called elapsed real time. There is another method called, for example, system called alarm manager .rtc. In that case, instead of this, if we had used RTC, in that case the alarm follows the wall clock time, that is the clock of your system. So it doesn't go off like go off after 1 minute or 5 minutes, but it goes off at a given time. So it depends on the uses. So currently we have a uses scenario where we want it to go off after 1 minute. Now let's just add some code to test our alarm. So let's go to photo gallery fragment and let's go to its onCreate method. And in the onCreate method, instead of doing this, which we were doing earlier, which was really basic, we will now do poll service dot set service alarm get activity true. So this should all ideally set our alarm. So let's run the program and then see what happens. So we will run the program and we have pressed the back button immediately. Now in our logcat, let's see what is happening. Let me search for poll service. So as you can see that even though we exited out of our application, the poll service is carrying on. So poll service is not stopping, poll service is carrying on. So this behavior is of course maybe extremely annoying or maybe extremely useful because you created the service and now it is continuing even though you are out of the application. So let us see how we can use this. So for the time being, maybe we can go to the emulator and just remove the poll service from here. Just remove our photo gallery from here. So as we could see that service keep running even when we have pressed the back button or have gotten out of the activity that started the service. Now this is a good thing and also a bad thing. It is a good thing if we want a task to continue. For example, if I am doing data collection on my mobile phone, then maybe I will want the data collection to continue even when I am out of the application. But it is also a bad thing that besides being annoying, it may be very much energy consuming and it may stop your mobile CPU from sleeping. So it may lead to energy consumption, which means that the mobile device will run out of battery power and will stop working. So we have to be very careful when we use services. So like just in this example, let's try to say that let's try to use it judiciously. So let's write some more code towards that. Now, for example, when we come to the alarm manager, if you see that we had set it up to set inexact repeat, there is another setting which says set repeating. So the difference between set inexact repeating and set repeating is that set inexact repeating is flexible, which means that it allows Android system to group your alarm with other such alarms. So that means that your Android system can batch your alarm with others, and therefore it may minimize the amount of wait time needed. On the other hand, if you do the set repeating, then the alarm is set to repeat at exact interval. So that is what the interpretation of set repeating and set inexact repeating is. Now, till Android 4.4 or Android KitKat, that is API 19, this was the behavior of set repeating and set inexact repeating, which was enforced by Android. That is, set repeating was exact repetition and set inexact repeating was inexact repetition. However, since Android KitKat, Android has changed the behavior of both methods, and now set inexact repeating or set repeating behave the same way. That is, they set the alarm for inexact repeating. Additionally, the restriction on using one of the predefined interval constant has been removed. So using a custom interval for either of the method still results in inexact repeating behavior. So in fact, the notion of exact repeating has been done away by the Android since API 19, because it was observed that exact repeating was causing a lot of energy consumption. So now if you do want that, then you will have to use some new methods such as set window or set exact, which are available with Alarm Manager, which allow you to set an exact alarm to occur only once. But set and exact repeating and set repeating now behave the same way. Now, the second important thing to consider with Alarm Manager is the time basis option. So here, for example, we are using elapsed real time. We could have also used RTC. So the difference between these two is that elapsed real time counts the time relative since the last boot of the device. So this is very good for our current applications where we only want to check or poll the service after a certain time has passed. On the other hand, the alarm manager.rtc uses the wall clock time, that is the clock time of your device, and that may be useful in certain situations. However, in this case, that was not the useful one. Now, if you are only using elapsed underscore real time or .rtc and your device is in sleep mode, that is the screen is turned off, then alarm will not run. So in case you want the alarm to run, then you will have to do something else, which is called alarm manager dot elapsed real time wake up or alarm manager dot rtc underscore wake up. So these two you have to do if you want your alarm manager to wake up your device and then do the alarm. So this may be useful in certain situation. However, you should avoid it because waking up a device means more energy consumption. Now in this program we also use something called pending intent. So a pending intent is a token object, and when you get one here by calling pending intent dot get service, essentially you are saying to the OS, hey, please remember that I want to send this intent with start service intent. So later on when you call send on your pending intent token, then the OS will send the intent you originally wrapped up. So in this case, we originally wrapped up the poll service intent with our pending intent, and when we called the send, then that intent was sent. So for example, here using the alarm manager. So now you can use the pending intent in multiple ways. For example, you can give pending intent token to someone else and they use it. It sends that token as your application. Also, because pending intent lives in the OS, you maintain control of it. So if you want to be cruel, you could give someone else a pending intent object and then immediately cancel it, so that send does nothing. So you control the pending intent object. And another thing with pending intent is that if you request a pending intent twice with the same intent, you will get the same pending intent. So you can also use this attribute of pending intent to test whether a pending intent already exists. So essentially you use pending intent when you want to deliver a certain type of intent at a later time. So here in this case we wanted to deliver the poll service intent at a later time, and that's why we use the pending intent. And in general you can use only one alarm with the pending intents, just like you saw here that we can use only one alarm, and it is used like this, that if is on then send it, otherwise cancel the alarm. And because we cancel the alarm, we also cancel the pending intent. So now let us add some more code, essentially a code like is service alarm on, and let's see that what we can do with that. So we work in the same file poll service and we add another method. New intent context, then we create a pending intent, pi equal to pending intent dot get service context request code, then we serve the intent then we serve the flag. So pending intent dot flag underscore no create, return pi not equal to null. Let's try to understand what we are trying to do with this method. So number one, let's start with the flag. So this flag says that if the pending intent does not already exist, do not create it. So here what we are trying to do is that we are trying to because with the alarm the pending intent also gets cancelled, so we can, so if we know that the pending intent exists, it means the alarm exists, otherwise even the alarm does not exist. So this is the method to check it, that you pass a flag dot no create, and then through that you can see that if the pending intent doesn't exist, then the service alarm is not on. Now let us talk a little bit about controlling your alarm. So now you can see that you can turn your alarm on and off. Let's add an interface to turn this thing on and off. So let's go to the menu and add a menu item. So the menus, as you know, are given in the menu folder here, and we will go to fragment photo gallery.xml, and in this we will create a new item slash item Android ID equal to at plus ID slash menu underscore item underscore toggle underscore polling. Android provide title equal to add string slash start. So we will have to create this string resource. App show as action if room. Okay, now let's add a new string, start polling. Let's also create another string resource because we will be needing it. Its name is stop polling. So yeah, and then maybe few more. New pictures, go title, new photo gallery, pictures, new pictures underscore text, you have new pictures. So that is few strings we have created, and now we are going to add some code into the photo gallery fragment on create method. So after the update items, this we can now remove. This is far too simpler. Instead, we add some code later on in the on options item selected. So on options item selected. So yeah, so let's add a new case. Case r.id.menu item toggle polling and boolean should start alarm equal to not poll service dot is service alarm on get activity poll service dot set service alarm get activity should start alarm, and we return true. Now with this we should be able to toggle our alarm on and off. But the menu item for polling will always say start polling. So even if the polling is currently on, so we should instead toggle the menu item title as we did for earlier for the show title in our report intent tab. So now let's go to the photo gallery fragment on create options menu. On create options menu. So type on create options menu, yes, and in this, after we have got this code, let's just do the same work which we did earlier in the report intent class. Go to menu dot find item r dot id dot menu item toggle polling if poll service dot is service alarm on get activity toggle item dot set title r dot string dot stop polling else toggle item dot set title r dot string dot start polling. Now the only work left is to go into the on options item selected and tell the photo gallery activity to update its toolbar options menu. So let's go to the on options item selected. So on options item selected, yes, and then in the toggle polling we will just say that get activity dot invalidate options menu. Now there is still something missing, but we'll come to that later. Let's run it for once to see that everything is compiling and is running. So no, not well formed XML token. Okay, sorry. So this is a minor mistake. Let's run it again. So here it is toggling, that is fine. So in this example, we learned about alarms, we learned about how to use pending intent, we also learned about background services. With services and activities, background thread, async task, now you know almost everything that is required to write good applications. Thank you.